Hi, this is my video that's going to cover 28, 30, 35, and 37. So you can scan through and only watch the ones that you need. And on this, we're supposed to verify the identity. So I'm going to work with the complicated side to make it equal the other side. I'll work with one side only. So when I look at 28, I notice I've got two terms and they both have a cotangent. So let's factor out a cotangent x, and we'd be left with secant squared x minus 1. This is a Pythagorean identity. Secant squared x minus 1 is equal to tangent squared x. And so cotangent times tangent. Oh, I love that because I realized they're reciprocals of each other. So let's change cotangent to tangent because we want to keep in mind our answer is in terms of tangent. So let's do cotangent as 1 over tangent x and tangent squared x over 1. If I have two of these and one on the bottom, I can mark a tangent out of both, kind of get rid of the power. And there we go. Number 30, I think I would say the left side is more complicated than the right. So, and I like the left side because I've got a difference of two squares. Is that the way I want to go about it? I don't know if that's the way I want to go about it, actually. Looking at where we're trying to go. Well, I don't really love that idea. What if we change cotangent squared to cosecant squared x minus 1? I don't love that either. Cosine squared over sine squared? Let me think on that one for a minute. Okay, I had to think about it a little bit. I am going to change cotangent to cosine squared x over sine squared x. And then I'm going to say, well, these are two fractions. Let's get a common denominator. So I'll multiply by sine squared x. You could have also butterflied. That gives me cosine squared x minus cosine squared x sine squared x all over our common denominator of sine squared x. Now I can factor a cosine squared x out of the numerator. And that's 1 minus sine squared x all over sine squared x. And this is that Pythagorean identity. So I get cosine squared x times another cosine squared x all over sine squared x. And if we want to pretend like, want to look at that as sine squared x times 1, then we could sort of separate them out. And this is cotangent squared x. And this is cosine squared x. All right, so truly, if at first you don't succeed, try again. 35, this is the even and odd identities. Cosine and secant are the only even functions, which means cosine of a negative is the same as cosine of the positive. And all the others are odd, which means the cosecant of a negative x is the same as negative cosecant of positive x. So that's the even odd rule. You could just look it up. That's equal to negative cosecant of positive x. And secant of negative x is the same as secant of positive x. And since we're trying to get to cotangent, I'm going to change them all to sines and cos. Do I want to change them to sines and cosines? Yeah, let's change them to sines and cosines. So it's negative 1 over sine x over 1 over cosine x. Keep, change, and flip. Multiply by that reciprocal in the bottom. That gives negative cosine x over sine x, which is negative cotangent x. All right, lastly, this is the cofunction rule, but it's squared, but that's okay. The cofunction rule says the cosecant of this is equal to its cofunction of the complement, and it's squared, so that's okay. And secant squared x minus 1 is the Pythagorean identity. It's just equal to tangent squared x minus 1. So I'm using the rule that cosecant of pi over 2 minus x is equal to the secant of x, and it's okay if they're both squared. So that's the only rule I use there. Alrighty, thank you for watching.